What if the center of a black hole was not a single mysterious point, but a boiling cauldron of tangled energy that never cools down? In the energy filament theory, the true core of a black hole is a stew of compressed energy filaments that are constantly rolling, shearing, knotting, snapping, and reconnecting. And the moods and outbursts we see from outside are just the surface reaction to that never-ending turbulence. In this picture, the stewed core sits at the deepest layer of a four-part structure. By the time anything reaches it, the outer pore skin has vented and sealed 1,000,000 times. The piston layer has swallowed and smoothed violent pushes, and the shredding belt has already pulled ordinary particles apart into raw filaments. So nothing arrives as atoms or matter, everything arrives as thread. Inside the core there are no neat particles, no fixed shapes, just a density of filaments so high that they behave more like a single churning substance than separate strands. You can think of it as a pot that is cooking noodles, stirring lava and spinning a whirlpool all at once. A superfluid typhoon eye in the energy sea where every thread is under tension, trying to slide, twist or latch onto its neighbors. Threads pull on each other and form knots. Those knots are ripped open by deeper flows. New loops appear, old ones are stretched thin and snapped. The whole thing is a fast, chaotic dance of filaments that never settles into a solid block. Every big roll in this stew sends out a pulse, a wave of extra tension and motion that climbs outward through the layers. First, that pulse slams into the piston layer, which responds by shifting its breathing pattern. Then the effect reaches the pore skin, which answers with a burst of tiny valves opening and closing. To a distant telescope, those internal mood swings show up as changes in brightness. The flicker of the inner ring, or the first push that feeds and shapes the jets that shoot away from the poles. It sounds abstract. Think of watching a thick soup on a stove. The bottom heats up, a blob of hot liquid rises, breaks at the surface, and collapses back down, only for another bubble to form somewhere else. The pot looks calm on average, but at any moment you can point to a swirl that is doing something dramatic. The stew core plays the same game, only its bubbles are surges of energy filaments. Its boiling sound is a mix of light and tension disturbances, and when it hits the lid, that could mean launching matter and radiation halfway across a galaxy. When the core is deep, dense and relatively steady, a black hole looks like a quiet giant. Its stew rolls in slow, powerful cycles, so its outbursts are rare but enormous, and its glow changes only over long timescales. When the core is more frantic, thinner, hotter, or being fed unevenly by new and falling material, the stew sloshes and snaps in a more nervous rhythm, and the whole black hole behaves like a restless beast, with rapid flares, jittery jets and flickering inner structure. Small black holes tend to have stewed cores like small pots on full flame. Each roll can send a noticeable kick into the outer layers, making them more variable and temperamental. Supermassive black holes at galactic centers are more like huge slow cookers. It takes much longer for a big volume of stew to turn over, but when it does, the effect can be felt across enormous regions of surrounding space. In this view, the personality of a black hole, its timing, its jets, its flashes is not some magical property of the horizon itself. It is the outward expression of how violently or calmly the stew core is churning at any given era. The outer layers are just translators, turning the deep filament chaos into the light and motion we can actually see. The core is the true engine, the place where all incoming complexity is melted into one language and all outgoing signals are born. In the next episode, we'll circle back to the horizon and ask whether that familiar dark ring is really a thing in space at all, or just the sharp visual border where light has been forced to give up trying to escape from this four-layer tension machine. Tap follow, share it on New Physics, Clear Universe.